Hey everyone, thanks for tuning in. This video is about how to use conversion factors, the ones that are on the board, to convert a quantity in one system of measurements to another quantity in a completely different system of measurements. In this video I'll be using cubic meters, cubic feet, liters, imperial and US gallons and kilograms as units of measures featured from the metric, imperial and US customary systems of measurement. In the first half of the video I will walk you through step by step how to use these conversion factors in a number of practice problems. In the second half of the video I will show you how these single conversions combine into a more complex word problem featuring multiple conversions. So single conversions first, complex conversions second half of the video. Before we get going with number crunching, I want to point out 5 different issues that affect the math with this conversion. First one is the decimal numbers. These decimal numbers all have 2 places here. In actuality, these 5 decimal numbers are either infinite decimal numbers with infinite decimal places or have at least 6 decimal places. So, in your line of work, in your industry, these decimal numbers might be rounded differently because they have at least 6 decimal places. So a wide variation of range exists in the number of required precision of the conversions. So if 3.78 is used, 0.78 can be used as just 0.8, is used as 3.8, I understand that can happen. 4.55 can be rounded as 4.6 or can also be sometimes used as 4.5. I know 5 we round up and 4 and below we round down, but in some contexts, in some industries, 4.5 is used. And I'm not here to argue with your industry, with your instructor, with your course book or textbook. I'm just pointing out that these decimal numbers all have multiple decimal places and they can be rounded differently as required by the precision in your line of work, in your industry, and with the commodities that you are converting to. So, the second issue is relating to commodities. These conversions, throughout the conversions, the numbers change. 1 becomes 3.78 or 1 becomes 4.55 or whatever, and the units of measures change. Imperial gallons become liters or US gallons become liters. So those things change, but 2 things remain the same. The commodity throughout the conversion stays the same, especially the liquid conversion ones. So if you start with milk, 200 imperial gallons of milk, you will end up with milk on the other side of the equation. The commodity will stay the same. The first one is cubic meters and cubic footage. It's empty space, it doesn't really have a commodity, but these ones here in the middle with liters, they relate to one liquid commodity, whatever you're converting, olive oils, gasoline, whatever. It could be cubic footage of LNG. Whatever you're converting, that commodity doesn't change. Also, the absolute quantity of the commodity doesn't change. That is, if you start with a barrel of milk, that barrel of milk does not change. It will remain a barrel of milk. It can be measured in imperial gallons. It can be measured in liters. The same barrel of milk can be measured in US gallons. It will remain the same barrel of milk. Okay? Whether you measure it in gallons, this kind, that kind, or in liters, or you can put it on a scale and measure its weight. The commodity doesn't change and its absolute quantity doesn't change. It is just expressed in different units of measures. I hope that makes sense. Now, to get going with the calculations, and I really can't sugarcoat this, you need to memorize the conversion factors with the number of decimal digits that is required in your line of work, in your industry. Now I know cheat sheets exist, and on forms and checklists these conversion factors can be printed in the corners. You still need to remember what to do with them, but it's also typically required that you remember the most often used conversion factors that you routinely use in your line of work. So the extent of memorizing the conversion factors is up to discussion, but some memorization is typically involved. Beyond memorizing numbers, this is issue, number 4, you also need to memorize what unit of measures the conversion factor ties together. The conversion factor 4.55 only relates to imperial gallons and liters, nothing else. It doesn't work with kilograms or pounds or whatever. It doesn't work with anything else. Only imperial gallons and liters. The conversion factor 35.31 only relates to cubic meters and cubic feet. It does not work with cubic kilometers. It does not work with cubic inches. It doesn't work with anything else. Only cubic meters and cubic feet. So, to illustrate this, if I remove the words that indicate the units of measures, you can see the numbers become nonsensical. 1 does not equal 4.55. 1 does not equal 3.78. Because you need the words here. 1 watt equals 3.78 watt. Okay, so you can't leave out the units of measures. So, have to memorize the conversion factors with the necessary places of decimal digits and the units of measures line by line, what the conversion factors relate to. I want to point out 2 other things here, and I hope you're not dyslexic with this one. Look at the numbers on the left hand side of the equal sign here. The numbers are low, 1, everywhere. On the right side, the numbers are higher. Everything is more than 1. 3, 4, 35, 28. So, the numbers are small. Here, the numbers are big. But on this side, the units of measures are big. I know, I just said the numbers are small, but I'm saying the units of measures are big. Let's go back. An imperial gallon, which looks like this, something from the janitor's closet. They're probably still looking for it. An imperial gallon is bigger than a liter. The liters here are small. The gallons here, either US or imperial, are big. Likewise, a cubic meter of space is 1 meter by 1 meter by 1 meter. It's bigger than 1 foot by 1 foot by 1 foot cubic foot. Bigger unit, smaller unit. Smaller number, bigger number. I hope you're not dyslexic here. But visualizing is an important part of the math that's to be done, because what you do with the conversion factors comes out from either visualizing or from directionality. Let me explain directionality. So the original sense of the conversion factor 4.55 ties imperial gallons and liters, but in a fixed order, starting with imperial gallons, ending up in liters. If this is the exact direction conversion is to be done, conversion factor will be multiplied in the math operation. If you start with liters and convert them to imperial gallons, you're going the opposite direction. To undo a multiplication, you need to divide. So directionality will, the same conversion factor is used, but directionality will tell you whether you times by that conversion factor or you divide by that conversion factor. It's really important. So that's directionality, or you can visualize the problem as follows. A larger imperial gallon with the smaller number, larger gallon, is able to fill multiple smaller units, liters in this case. One big fills multiple smaller ones, or multiple smaller ones are are needed to fill one of these. Therefore, it's a multiplication relation. If you're going the other way around, say you have, I don't know, 20 liters of liquid commodity, I don't know, 20 liters of, how about whey from cheese manufacturing, 20 liters of whey in a tank, it's a small tank. To measure its quantity and express it in imperial gallon, you're dividing a 20-liter tank into smaller chunks, imperial gallons, and it's a division problem. You start with a tank that has so many liters of stuff, commodity in it, and scoop by scoop you're filling the first empty jug in imperial gallons, and then the second one, and then the third one, and the fourth one, as many as needed. So that's another way to visualize multiplication versus division. So this kind of thinking needs to be done by you and is not coming out of anything else that's indicated on the paper. Let me show you how the conversions have a pattern, how they look like on a paper. There's a given side to a conversion, and the other side of the equation is the requested side. On the given side, you have a quantity you start with, a number, 5, 408, 0.02, whatever. And there's a unit of measure, kilometers, miles per hour, gallons of whatever, cubic feet, something. You have a unit of measure here. Then you have a requested quantity, that's to be calculated, and there's a blank line underneath there, and the unit of measure that's also given, but it's on the requested side because you need to know what to convert into what. So you also have that unit of measure there. Let's take a look at a practice problem. This is how a practice problem looks like. So here's your first quantity, 5.1, and here is your first unit of measure, imperial gallons. Here is the requested quantity to be calculated and the answer written on the line, and there's your first requested unit of measure. Now, to do a conversion, you need to remember your conversion factor, but which one? Well, the one that ties imperial gallons and liters together. There's only one conversion factor for that, and that's 4.55. What do you do with the 4.55? Well, you can either visualize it or look at directionality. I will do both here. So the original sense of the 4.55 conversion factor starts with imperial gallons and ends up in liters. This is the same direction. This conversion is requesting that this 5.1 be converted to another quantity. Therefore, is going to be a multiplicative use of the conversion factor 4.55. When you enter it in your calculator, this is what you enter. You enter the original quantity multiplied by 4.55. Now to visualize it, this is how it looks like. Each imperial gallon needs 4.5 of these, so you scoop, and 4 of these plus a half will fill 1 imperial gallon. When you have multiple imperial gallons, you need multiple liters to fill. If you have just one, you already need multiples of these to fill one of these, and if you have multiple imperial gallons, you need multiples of multiples to fill all of the, say, empty jars with liters, something like that. So that's another way to visualize this. It's a multiplication. Have a reality check on the numbers. 4.5 can be visualized as 4 because it's easy to do math with, and 5.1 can be just 5. 5 times 4 is 20. You need to see at least 20 liters on the answer sheet or on the answer line, and if you do the decimal numbers accurately, you are going to get on your calculator screen 23.205. Now, that from the screen needs to be from the screen, that's what this line here represents, your calculator view, needs to be copied on your answer sheet accurately, ideally, without being dyslexic with the digits. So pencil your answer in, or write your answer in on the answer line. Now, let's take a look at how this conversion looks when the units are reversed. 83 liters is to be converted to imperial gallons. Of course, you need to remember your conversion factor, 4.55, because that's the only conversion that ties together liters and imperial gallons. Because the original conversion, the sense of the original conversion factor is to convert from gallons to liters, and now we're doing it backwards. 4.55 will be used in division. That's why this is what you enter on your calculator, press equal, and you'll see that number. If you visualize this, again, you have 83 liters in a tank or a barrel, and these 83 liters are scooped out 1 liter at a time, poured into empty jars until all the contents, all 83 scoops later, when all the contents of the tank or container is gone. Let's see how many of these smaller gallons you have filled up. Well, it's going to be 18 plus a little bit in one of them, 18.241 it is. So that's looking at it, visualizing and having a sense of division. Let's look at another one and let's think it through. Oh, sorry, that's how it looks like when you copy the answer accurately. So let's look at another one. Let's convert cubic meters to cubic feet. You need to remember, of course, your conversion factor, 35.31. Now, cubic meters are larger, 1 meter by 1 meter by 1 meter, and into each cubic meter you can stack 35 smaller cubes, not these ones but smaller cubes, each a cubic foot. So that's the sense of the conversion factor, to convert from a larger cubic foot to a smaller, from a larger cubic meter to a smaller cubic foot. So, because this is a conversion in the original sense of the conversion factor, this is a multiplicative conversion. There's your conversion factor is multiplied with the original quantity. You do this on your calculator, you'll see that number. Make sure it's copied accurately on your answer sheet. Let's take a look at one more and let's think it through. Let's convert from kilograms of water, don't forget that, at 4 degrees, at 101.325 kilopascals of atmospheric pressure. So this is a special case of commodity. So many kilograms of water that can be scooped easily, because each liter at this temperature and at this pressure, each liter that you can scoop is 1 kilogram. So many kilograms of water needs to be converted to cubic foot. So you're filling cubic foot cubes with liters. So 95 scoops plus a little bit more later, how many cubic feet will you be filling? Well, less than 95. The conversion factor between the two of them is 28.32. So 95 gets divided into a smaller chunks, 28 scoops, 0.32 will go into each cubic foot. You will have 3.3 plus change cubic feet filled with this original quantity of water. I hope this makes sense. That as it's visualized, it can also be thought through in terms of directionality. The original conversion factor, 28.32, ties cubic feet first, 2 kilograms when it relates to water only. And because here it's reversed, therefore instead of multiplication, this is a division. So it can be reasoned either which way. Make sure you copy your answer accurately on your answer sheet. So those were single conversions and fairly simple conversions. Again, you still have to think what you do with your conversion factor, because there are no hints anywhere else on the sheet. Let's take a look at how they look in a complex word problem. This is one example of that. This is everything to it. Let me explain. Typically it starts with a simple calculation, calculating the size or calculating the volume of a some kind of tank that's either rectangular shape or cylindrical or conical or some kind of geometric shape that can be easily calculated. And there are some numbers for the calculations. So in this case it's rectangular, it has a length, a width and a height, and it's easy to calculate its volume in cubic feet. So that's where that's the first line that gets done, and that's a calculation. But the rest of them are all conversions, and they don't get done in first, second, third, fourth and fifth order. You have to figure out which one of these which one of the conversions can be done right after you're done with the calculations, because you have to think through. You will have some cubic feet here. What needs to be converted, what can be converted to what first in order to solve all of the practice problems. Now, one of them is this 10 covered, because it ends with pounds, and in this video alone a conversion factor tying pounds to anything wasn't featured. So that's a new number that needs to be introduced, and it wasn't part of this video, but it's part of a typical word problem. You can see how these relate. It can also be done, instead of feet, it can also be done with meters, meters and meters to get cubic meters. And then, so instead of imperial or English units of measurement, it's now metric. So it has both variants, but even so, you still have, even if it starts as metric, you still have US and imperial gallons, liters, kilograms and pounds, because these are typical conversions to be done in a number of occupations. So pause the video and do your thinking, which conversion gets done first, and then from that what other conversion can be done. So what's the sequence of conversions here that are doable using the conversion factors that are factored in this video alone, except this line here, so don't do that one. Alright, let me show you the answer key here. So the first calculation, 2 times 3 times 4 is just 24 cubic feet. That's very straightforward. What do you do with cubic feet? Cubic feet can be converted to liters because you have a conversion factor that ties cubic feet and liters together. And our conversion factor is 28.32. 28.32 will be multiplied by the original quantity, 24, because that's the original sense of the conversion factor, 28.32. Liters are also smaller, so multiple units of liters can be filled into a fairly larger cubic foot. In all, you will end up with 679.68 liters. So that's your answer for the first conversion. The second conversion looks like, the second and third conversions look like this. You can do both of them starting from liters. And I'm going to discuss the benefits or problems associated with this. So this one is liters here, and you piggyback this number to be the first number in the next calculation, and to be the first number in the third calculation as well. If you do that, you can use a known conversion factor, 4.55 and 3.78, to end up with imperial gallons and US gallons. Nice. But there are risks involved here, namely two kinds. You're piggybacking a number that, if calculated wrong, these other two conversions will also be wrong. So if there's a boo-boo in this calculation somewhere here, these other two calculations, derivatives of the first one, cannot possibly be right. There is a way to minimize this error and minimize this problem. I'll show you how the solution looks like on the last slide. Another issue associated with this is that if this number happens to be an infinite decimal number, it gets rounded or truncated, or it gets less precise when it gets entered as the first number of the next calculation. It also has multiple digits, so copying the number accurately from the previous number that you pencil down, there are copying errors, possibility of copying errors involved, being dyslexic with the digits, or omitting important digits for the calculation. So the actual precision of 149.38 is not too great, because even if the numbers are copied correctly, you're still using the conversion, you're still converting a previously converted amount. So you have a conversion of a conversion, and it just is less precise than another way that I'm going to show you on the last slide. One other conversion that can be done is fairly straightforward. 1 liter on the bottom here is just 1 kilogram. It's a 1-to-1 conversion. And so if the commodity is water, and if this water is at 4 degrees Celsius and measured on a scale in kilograms at standard atmospheric pressure at 101.325 kilopascals. So that's a straightforward conversion. On the last slide here, let me show you the solution here to this problem of eliminating some of the precision issues. So here in purple, I just repeated the numbers, but I have a better or different approach. Instead of piggybacking this number here and here, I have a different conversion factor that converts or ties cubic feet to US gallons or cubic feet to imperial gallons. A direct conversion, starting with the original amount. This one is not an infinite decimal number, it's a whole number, so it eliminates that problem as well. Now, of course, if you have 2.3 feet and 3 point something feet, you will have still fixed number of feet. This can be an infinite decimal number, but you're still working with the original quantity. Here you're working with the original quantity. Starting with the original quantity is better than converting an already converted amount. So here 24 is featured in these conversions to start with, and they are multiplied by a conversion factor that's featured in another video where their meaning is explained as well as how they are used, but it ties cubic feet and US gallons directly to each other, or cubic feet and imperial gallons. Lastly, how many pounds it weighs of what, if it's water and exactly at that temperature and pressure that I mentioned. You have two options for two different conversion factors. 2.2 could be used because 2.2 pounds make a kilogram. This conversion factor is also new, it wasn't featured in this video. But using 2.2, again, piggybacks that number, the 679 liters. So this again is a conversion of an already converted amount. So instead of 1,495 pounds plus change, I have a more precise approach here, this one, 1,498 pounds, which uses the original 24 cubic foot amount and uses, instead of the 2.2 conversion factor, 1 kilogram is 2.2 pounds, directly ties cubic feet together with pounds of water, and a conversion factor. And in this case, the temperature of the water is different, but the conversion factor is 62.42 pounds. So when these two numbers are multiplied, this number, this final number, 1,498, is more precise than the 1,495. So that's a 3 pound or so difference. This one is more precise for the reasons that I explained. Likewise, 149.5 is more precise than 149.4. The difference is little, and I recognize that your answer keys for your tests may vary depending on what conversion factor was used. All of these conversion factors have multiple decimal places. All of the conversion factors are rounded numbers, so whichever you will use, they will result in slightly different decimal numbers. Sometimes it's like 3 pounds, like this. So that's just a little snapshot of the complexity of word problems and complex conversions that are built one upon another. It's a long video. Thank you very much for watching.